Can you please flip to the quick notes? Applications of arithmetic sequences. So we talked about arithmetic sequences, add or subtract. I might add that note. They add or subtract. Arithmetic sequences have a common difference, and we use lowercase d to represent that. In lesson 1.1, we talked about a recursive rule or equation. Today, we're going to talk about an explicit equation or rule. So we've already written recursive rules for arithmetic sequences. Today, we're going to add an explicit rule. Okay, and we're always going to start with a sub n. That's how we name a sequence, rule, or equation. I'll put equation. Parentheses. We're always going to start with the zero term, a sub 0. The zero term. Plus our common difference times n. Where n is the term number, it's the input. Think about it like function notation. It's what goes in. What comes out is a sub n. That's our output. This would be what comes out of it. So we've got some explanations for what each thing means. We've already talked about d. d is your common difference. It's what our pattern is changing by. You want to try some examples together? Sure. Let's do number 1 in the check. If you have a rewards card at Big B Coffee, you earn a free drink after every 12 drinks you buy. Can the total amount of money spent at Big B after ordering N drinks be considered arithmetic? Why or why not? Turn and talk to your team. Is that arithmetic or not? What do you think? Turn and talk to your team. What do you think? Great. Negative common difference. What is a negative common difference? It's going down. Good. It's going to be going down. Let's see. You've got some examples here. A, B, C, D. I want you to turn and talk to your teams. Determine whether each sequence is a negative common difference. Explain your reasoning. Turn and talk to your team. You're looking for a negative common difference. Does it have it? Oh. This is not an example of increasing. Decreasing. This would be an increase. Your car odometer goes up. That is not an example of negative common difference. How about this one right here? How about this graph?
Because it's moving in a positive direction, but it goes under into the negatives.
I'm just going to connect them. What do you think?
Well, it's going down.
It's going down. I agree. It's going down. But if I connect those, what does that look like?
A quadratic.
Quadratic. It could be a quadratic. It could be a lot of different things. What did we talk about in the graphs in our classwork? Linear patterns. So this is going to be a no. We've got a curve. It's not a linear pattern. Okay, how about D? Is that an example of negative common difference?
Yes.
Down 5. Down 5. Down 5. This is the only one. This is a negative common difference. Yay, that's the only one. Great. I hope we're seeing some examples, some real-world examples. We're going to do one more together, and then we're going to do our homework. One more. A family cell phone plan. Applicable, but cell phone plans are constantly changing. A family cell phone plan is sold for $35 a month for the first line and $20 for each additional line. You need to write a recursive formula and an explicit formula. Yesterday we practiced the recursive formula. It is a sub 1. What's the first month or the first line going to cost us? 35. What is each additional line going to cost us? It's going to cost us that common difference. Thank you. What's that common difference? We're going to be adding what each time? 20 per user. Okay, this is what we did in lesson 1.1. Okay, so we practiced that yesterday. That's 1.1. Today we added in the explicit formula, our rule. Okay, so I'm going to start with a sub n. This one's a little tricky. 35 is the first term. And I want to know the zero term. So I have to work backwards one. What would the zero term be? If I defined a sub 0 and I went backwards, it'd be what, Gavin? $15. It'd be $15. Do we see how I worked backwards? I took the common difference. I subtracted it from the first term to get the zero term. Magic, not magic. If we just make a table, you don't have to write this, but if you're struggling, it's okay. N, a sub n. They told us that the first month is $35. The second month's going to be $55. The third month's going to be $75. If I went back 20, the zero term would be 15. That's all we're doing. I'm making a table in my head. If it helps you, make a table. So now it's going to be $20 times what? What's our variable? Are we using x, y? N. And that's the explicit formula. Questions? You ready for our homework? We're going to practice this. We got lots of time. We have 30 minutes. We're going to get our homework done. 30 minutes. We're going to practice this. If you have any missing homework, now would be a good time to check it in with me. If you need to go to the bathroom, now would be a good time to check with me. Yes. Homework? Cool. I'll take missing homework at my computer.